morning or afternoon, depending on where you are joining us from. Before we get started, we're fortunate to have an interpreter, Natalia, providing live Spanish translation. To access interpretation, please click the globe icon at the bottom of your screen and select your preferred language. Thank you so much for joining us for today's webinar, Understanding Contaminants and Community Solutions in the Mississippi River Basin. With Earth Day tomorrow, today's discussion feels especially timely as we reflect on safeguarding our water and its impact on our environment and future. My name is Vanessa Munoz, and I am the Watersheds and Waterways Program Manager at Hispanic Access Foundation, a nonprofit that develops and connects Latino leaders to influence systems, shape narratives, and drive lasting change. Through trusted relationships and regional networks, we strengthen community power and advance a thriving nation. Today's session features an in-depth conversation with regional expert Josh Wolf from the Upper Mississippi River Basin Association. We'll explore critical water quality challenges affecting the Mississippi River Basin, including how contaminants move through the watershed and impact ecosystems, drinking water supplies, public health, local economies, and downstream communities. This will be followed up by a Q&A session where we'll address your questions. So please feel free to submit the questions throughout the webinar using the Q&A function. With that, let's get started, and I'll turn it over to you, Josh.
Hello, everyone. Thank you for joining us today. Thank you so much, Vanessa, for having me. I'm really excited to be here today with the Hispanic Access Foundation to talk about the Mississippi River. So we'll go ahead and get started. First of all, who am I and why me today talking to you about the river? I have dedicated my professional career to focusing on water. I am just fascinated by the way that water is tied to our lives and how we all interact with it. It's the one thing that binds us all together. No one can live without water. And the Mississippi River, in particular, is the primary artery of North America. It's the most important water body on the continent, and it drives so much of what happens at the continental scale. So a little bit about me. I started my career actually as a teacher. I taught elementary school, special ed elementary school in Memphis, Tennessee. And then I went back to school to learn about water. I did a Master's of Science in Water Resource Management and an MPH in Public Health focused on epidemiology. And there I looked at drinking water and diseases found in drinking water. My professional career, I worked for Salt Lake County Environmental Health in Salt Lake County, Utah. Then I moved back to the Midwest, where I worked for Minnehaha Creek Watershed District, which is a local watershed here in the Twin Cities. And now I work for the Upper Mississippi River Basin Association, which is based in Edina, Minnesota. I'm joining you today from Northeast Minneapolis, Minnesota. And if I look really far out the window, I can actually see the Mississippi River. I live about 2 blocks away from the river in Minneapolis. So it's really cool to have that connection to the river, both in my personal life. When I go run, I run along the river. And then when I work on the river all day. Let's talk about the Upper Mississippi River Basin Association, which we'll refer to today as UMRBA. So UMRBA is the governor-appointed interstate organization. It's the governor-established forum for interstate water resource planning and management on the Upper Mississippi River, representing its member states of Illinois, Iowa, Minnesota, Missouri, and Wisconsin. We work with state and federal agencies to facilitate cooperative action through cooperative planning, coordinated management, information exchange, regional positions on issues with the river, and advocacy on the state's behalf. For our presentation today, I'm just going to go through what we'll be talking about. We'll take a look at how the river works and how we manage the river. Then we'll talk about water quality in the river, looking at Gulf hypoxia, and then we'll review a report called the How Clean is the River report that was written by UMRBA. Then we'll talk about the Hypoxia Task Force, which is an EPA program, and we'll talk about nutrient loss reduction. And then we'll talk about what UMRBA is doing as far as collaborative solutions to these problems. And lastly, we'll talk about how you can get involved. So, where are we and what are we talking about? What you're looking at on the right is a map of the 5 upper basin states. And you see the dark blue line. That line is what's called a Huck 2 watershed. But first, what is a watershed? A watershed is an area where all of the water in the system flows to a common pour point. Now, watersheds are determined by people, but they function in nature within their own bounds. So we do our best to represent the watersheds on the map in the way that we believe them to operate on the land, but there's always going to be a little bit of interpretation. So looking at the map, the big blue line is what's called a Huck 2 watershed, and that is the upper basin. And the smaller gray lines that you see, those are the Huck 8 watersheds, and they go all the way down to Huck 12. And so these are delineations that are made by the USGS, the US Geological Survey. So a little bit about the river. The upper basin is 1,250 river miles out of a total of 2,340, which makes the Mississippi the 3rd longest river in the world. The Mississippi River provides drinking water for 18 to 20 million Americans every day, and it's responsible for 60% of the national corn and soybean exports. It's divided into an upper and a lower basin. Today, we'll mostly be talking about the upper basin because that's where my work is focused. The source of the Mississippi River is Lake Itasca, which is a small glacial lake about 1.8 square miles big in central Minnesota. And we'll talk about this on the next couple slides, but importantly, the Mississippi River has been modified for navigation for 150 plus years. And what that looks like is there's 29 locks and dams along the river. So the river is no longer a natural system. It's been managed for navigation for more than 150 years. When we talk about navigation, what we mean is the barges that you see in this picture on the right. Each one of those barges holds as much as 80 semi-trucks. This makes transporting goods along the river highly efficient. More recently, the river has been recognized and managed as an important natural resource. These management priorities are often at odds with each other, making management of the river very complicated. So the upper Mississippi River is what you're seeing in the map on the left. So we split this river into 3 different sections: the upper impounded river, the lower impounded river, and the open river section. So the upper is the green, the orange is the lower, and the open river is in purple. And oftentimes the Illinois River is included as a part of the upper basin when we talk about it, but we will be focusing on the big river today. And looking on the right, that's showing how the river is broken up into basically a ladder. It's a series of pools that steps the elevation down from where it starts at the first lock and dam, which is near the confluence of the St. Croix and the Mississippi in Minnesota, all the way down to where the Ohio River hits the Mississippi River, and that's the end of the managed river section. So the river flows roughly 1,300 miles from Lake Itasca to where the Ohio River meets the Mississippi at the southern tip of Illinois. This constitutes over half of the length of the river as a whole. Approximately 850 miles of the river, extending from Minneapolis, St. Paul, Twin Cities, to the Ohio River, is navigable by barges. 670 miles of this is controlled by locks and dams. There's 29 locks and dams, most of which were built in the 1930s, which create a stairway of water. That's what you can see on the picture on the right-hand side. In addition, the river is dredged to maintain a minimum channel of 9 feet deep so that barges can get through year round. The Mississippi River is a vital resource for economic prosperity. The economic sectors of the Upper Basin and the Illinois River generate more than $548 billion annually and support more than 1.8 million jobs. $54.6 billion from tourism and recreation also supports over 680,000 jobs. And you can see on the chart, this is the breakdown of the economics of the river system. Recreation visits to the Upper Mississippi River exceeded 11 million trips in recent years, which is more than most national parks, including Yellowstone. There are approximately 500 boat access points and marinas along the upper river between the headwaters in Minnesota and the confluence with the Ohio River in southern Illinois. But the river has ecological value too. It's not just about economics. There are 3 national wildlife refuges along the upper Mississippi River, totaling over 285,000 acres. They include the Upper Mississippi River National Wildlife and Fish Refuge, the Trempealeau National Wildlife Refuge, and the Mark Twain National Wildlife Refuge. The 5 Upper Basin states also manage an additional 140,000 acres of refuge lands along the river. The river supports more than 127 species of fish and 30 species of freshwater mussels, and nearly 300 species of birds migrate through the river valley in the spring and the fall. The Mississippi River Flyway is used by more than 40% of the migratory waterfowl traversing the US, which is actually happening right now this month. I've been looking for migratory species outside my window and haven't seen any yet, but they're coming. They're coming through currently. So, the Mississippi River is the primary driver of Gulf hypoxia. What is hypoxia? Hypoxia is a lack of oxygen in a water body. When the level of oxygen reaches a critical low, nothing can survive. Creatures that are mobile leave the area, and those that are unable to leave perish. Since 2001, the EPA has sought to reduce the levels of hypoxia in the Gulf. The Hypoxia Task Force works to collaboratively address nutrient loading in the Gulf. The task force is made up of 12 states, federal agencies, tribes, universities, and sub-basin committees. UMRBA is the sub-basin committee for the upper basin, and then there's the lower basin as well. The Gulf Hypoxia Program was authorized and appropriated by the Bipartisan Infrastructure Law. That money was appropriated for fiscal years 2022 through 2026, and UMRBA is working at the federal level to ensure funding continues for the program. The program provides dedicated funding for the 12 hypoxia task force states, eligible tribes, sub-basin committees, and the Sarah 46, which is a group of the land-grant universities. So we're looking here on the screen, we can see the hypoxic zone represented in 2 different ways. At the top is a map of the hypoxic zone, which is made from satellite imagery and then is ground truth. When we say ground truth, people from Louisiana State University once a year actually take a boat out and drive around the outside of the hypoxic zone with a sensor to test for where the hypoxia starts and ends to try to determine the edge. And so then the scientists compare what they've seen from the satellite sensors to what they've been able to map with the on the ground sensors from the boat. And that's how we get an accurate picture of the hypoxic zone. And then looking below, that's a satellite image of the zone from space. So let's look at the two primary drivers of hypoxia in the Gulf, nitrogen and phosphorus. The values that you're seeing on the chart show trends for the river as a whole, and in the coming slides, we'll look just at the upper basin. So if we're looking at the graph, we can see that the red line is a 45% reduction target. That's the ultimate goal that was created by the Hypoxia Task Force by 2035. And the maroon line above that is a 20% interim goal. You see how the line becomes dashed towards the blue line becomes dashed towards the end. That's because we're working with 5-year rolling averages, and it takes a number of years in order to ensure the accuracy of the average. So when we estimate the concentration of substances in the river, we use flow normalization. This is because raw concentration values can be misleading. As an example, a high concentration reading during a dry period may be due just to low flow volume in the river, and not a true increase in the load of the pollutant. The Hypoxia Task Force set a target of 45% reduction of nitrogen and phosphorus to the Gulf by 2035. You can see the reduction target as the bright red line on the graph. The task force also established an interim target of 20% reduction for 2025, which I'm happy to state has been met on schedule. The total nitrogen loads decreased below the 20% interim reduction target during 2024. Overall, the change in flow normalized loads between the baseline period, that's from 1980 to 1996, which we use to compare all the recent data against, was estimated to be a 27% decrease. In contrast to the total nitrogen loads, total phosphorus loads have increased somewhat since the baseline period, and the flow normalized loads were still above the interim reduction target in 2024. Overall, the change in flow normalized total phosphorus loads from the baseline was estimated to be an increase of 9%. So now we'll talk about how clean is the river report. What is the river report? This report evaluates 19 key water quality parameters on the upper river basin section of the Mississippi using data collected from 1989 to 2018. This provides both a condition assessment and a long-term trend analysis of the Mississippi River. So what you're looking at is the full trend results from the How Clean is the River report. On the left is the upper impounded section. In the center is the lower impounded river, and to the right is the open river section. I understand that there's a lot to look at here, and it's really small. But the most important thing for us to look at is to see the different colors. Red is bad, and green is good. So we can see by looking at this that there are both positives and negatives, and they're about equal in measure. Some notable highlights. Total suspended solids, that means the total amount of sediment that's in the river at any given time. They're decreasing in nearly every site. Total phosphorus is decreasing in most sites in the upper river, and some of our heavy metals, lead, arsenic, zinc, copper, are also decreasing at most measured sites. There's some issues though. Conductivity is increasing at nearly every site measured. Chloride is doing the same. Sulfates are also up in a few areas. We're going to dive deeper into some of these parameters next. Okay, so for nitrogen trends, let's take a look at this map. What you can see is we have arrows, and the size of the arrow determines the percentage increase. The bigger the arrow, the more percentage. The gray boxes means that there's no trend or there wasn't enough data to determine a trend. So we'll see this same type of chart on the next couple of slides. And this one is a little bit more complicated. The next will be a little bit easier to understand the way that the trends work. So this is what UMRB is doing to try and make sense of all of we know that's in the water. So nitrogen and phosphorus are present in the watershed in many different forms, such as ammonia, nitrate, nitrogen, and organic nitrogen. Total nitrogen is a measure of all of these different forms. Just like phosphorus, nitrogen is a key nutrient for plant growth. Biological processes convert nitrogen between the different forms, having significant impacts on algal growth and aquatic habitat. Excess nitrogen is flushed into the river through runoff and drainage from agricultural and urban lands and treated discharge from wastewater treatment plants. Although total nitrogen looks to be increasing above Pool 13, there's low confidence or no trend at most sites on the river. There is one high confidence decreasing trend on the Illinois River. Looking at this chart, we can get a better sense of how the arrows represent the trends because we have a much clearer trend for phosphorus in the upper basin. There's been an average 34% decline in total phosphorus concentrations in the upper reaches, but no clear trend in the lower reaches. Phosphorus, like I said, is a key nutrient for plant growth. High phosphorus concentrations drive excess algal growth that can cause low oxygen or hypoxic conditions. Organic matter from city wastewater, livestock and poultry manure, septic systems, and runoff carrying fertilizers are major sources of phosphorus in the river system. Phosphorus clings to sediment and is transported off disturbed lands with erosion and runoff. It may reside in stream banks as legacy phosphorus for decades. Significant improvements are the result of actions such as Clean Water Act compliance and wastewater treatment plant upgrades, along with decades of soil and water conservation work. We'll talk about what some of that work looks like in later slides. One of the most concerning trends in the river is chloride. More saline or saltier water harms aquatic ecosystems and is both expensive and impractical to treat. Essentially, once it's there, it's there. Chloride concentrations have increased by an average of 35% for sites with high confidence trends and are increasing throughout the entire river system. Chloride is a commonly occurring element that often bonds with other elements to form salts. Chloride makes the water saltier, which may harm freshwater aquatic plants and animals that are adapted to low salt environments. Runoff from de-icing salt from roads, sidewalks, and driveways is a major source of chloride to the river. Conductivity is a measure of the water's ability to carry an electrical current. Conductivity increases as the water temperature increases and with more dissolved salts and other compounds in the river. Significant increasing trends in conductivity throughout the system follow the trends of higher concentrations of dissolved salts like chloride in the waterway. Looking at some metals. Although the percent increases appear large for some metals, the actual concentrations are far below drinking water and aquatic life standards. Aquatic life standards is what affects the ability of organisms living in the water to be able to survive. Aluminum concentrations have decreased across the watershed, which is great news. Aluminum enters water bodies from the natural weathering of rocks and human sources like treated wastewater, industrial processes, and mining. In acidic waters, aluminum can be particularly dangerous for fish because it accumulates on their gills. Major sources of lead to the watershed are the combustion of leaded fuels, coal emissions, and discharges from mining and industrial sites. Lead emissions from burning gasoline and coal deposits on soils in the watershed are carried into waterways into the runoff. Though concentrations show increases, none of the field measured values exceed chronic criteria for lead. Zinc concentrations appear to have decreased throughout the watershed, but most sites have low confidence trends. Although small amounts of zinc naturally occur in water bodies, most zinc enters water from mining, the smelting of metals, burning coal, steel production, industrial waste, and urban runoff carrying tire residue. So that is a previous report that we've published. Now the UMRBA has taken that information and realized that we needed to do additional monitoring on the upper river. So we started a program that runs is currently running called our Fixed Site Monitoring Program. So UMRBA, in conjunction with state and federal partners, is currently monitoring at 12 sites on the Upper River. We started in October 2025, and we're continuing through September 2026. We're currently sampling for field parameters, bacteria, algal toxins, nutrients, dissolved metals, and recoverable metals. Most importantly, we're sampling for emerging contaminants. That's the pesticides and the PFAS, which we'll detail on the next slide. The table in the center is just a list of the sites that we're sampling at. And if you look at the picture on the right, that is a group of our samplers sending a water sampling bottle off of a dock with a custom PFAS-free sending device that my little sister, who's actually a welder, custom made up for us. It's pretty cool. So, emerging contaminants. This is the first comprehensive sampling of pesticides and PFAS that's been completed in the Upper Basin. You've probably heard about both of these in the recent news cycle. There's been several recent high-profile lawsuits regarding pesticides, and there's currently a nationwide focus on PFAS forever chemicals. Why are these forever chemicals? These chemicals don't break down easily in nature and can persist for decades or longer. UMRBA is analyzing 62 pesticides and the analytes. An analyte is the active ingredient in a common pesticide or a degraded form of pesticide once that breaks down in the environment. We're also sampling for 40 different PFAS species, and we'll have the results of that at the end of the year, hoping to publish by January. And all of that data will be publicly accessible. Thinking about what's next for emerging contaminants, the EPA has recently launched studies into a chemical called 6-PPD and 6-PPD quinone, which is a degraded form of 6-PPD. 6-PPD is extremely toxic to salmon species and other fishes. Additionally, microplastics have come recently into an increased focus at the federal level. Perhaps future monitoring projects through UMRBA or others might sample for these or other emerging contaminants we've yet to determine. All of this to say that water trends are really complicated. Looking at this figure, this is the magnitude and direction of annual flooding from 1920 to 2008. And looking at it, you can see it's just all over the place. The Mississippi River Basin is host to a variety of ecosystems, climates, and landforms. All this makes trend analysis particularly complicated. This is compounded by climate change creating uncertainty in long-term trends and altering long-established norms. One of the areas that is making trends complicated is legacy nutrients. An example of this is phosphorus. Once phosphorus enters a stream, it can either be transported downstream or stored in stream banks or within the riverbed. When phosphorus is stored in the stream bank, the nutrients can release over time, even decades later, causing what's called a lag effect or lag time. Lag time complicates environmental response as it can take decades to see results on the ground from conservation practices. This makes funding conservation challenging when results are not immediately visible. It also makes calculating the benefits of conservation practices more complicated, as it can take a really long time to see them play out in real life. If you're interested in learning more about our long-term research monitoring program, or if you'd like to read the full text of the How Clean is the River report, I have QR codes here that will take you to both of those resources. So what do I do? I'm the program leader for the UMRBA Water Quality Program, and we have 5 different pieces to our program. We have monitoring, nutrients, emerging contaminants, harmful algal blooms, and chloride. And today, we're mostly going to talk about the work that I've been doing with nutrients and the monitoring program. So first, we'll talk about our nutrient collaborations. Our goals are to strengthen regional collaboration, facilitate and foster cooperative planning and coordinated management, exchange information, identify priorities and actionable items for collaborative action, and to develop regional positions on water resource issues with the consensus from the 5 states. So we'll start by talking about multi-benefit conservation practices. This is a term to describe a singular conservation practice that provides more than one beneficial outcome. The beneficial outcome may be any combination of agricultural, ecological, social, and financial benefits. For example, a wetland has a potential to provide water quality improvement, flood mitigation, carbon sequestration, wildlife habitat, and many more benefits. Utilizing practices with multiple benefits may incentivize individuals based on their goals for their own land to improve natural resources both locally and in the upper basin. UMRBA created a series of workshops with stakeholders in the basin to discuss these types of practices. Now we're going to talk a little bit about what we found. The first thing we'll talk about is leverage points. Leverage points are areas where small changes can have outsized effects on the issue that we're looking at. We'll talk about some of the leverage points that UMRBA chose to highlight, which we learned from our workshops. So the first is technical assistance. Technical assistance is an important part of agriculture and conservation practices. With many recent advances in technologies, specialist assistance helps to maximize efficiencies while reducing inputs. This is a key leverage point. Funding is another key underlying factor in conservation practices. Seeking innovative solutions to funding needs, we can help to get projects off the ground. Peer-to-peer networks have been shown to be one of the most effective ways to influence farmers' uptake of conservation practices. And we'll talk a little bit more detail about this leverage point on the next slide. Forming new partnerships between new and veteran farmers, seeking collaboration between different state agencies, and connecting conservation groups with agricultural groups all can help us to utilize a shared body of knowledge we have about the basin in the most effective and efficient way. These are just some of the many partnerships that can help shape the future of the basin. A growing body of research has shown that peer group cohorts are one highly successful leverage point to increase adoption of conservation practices. Wisconsin's producer-led watershed groups are an excellent example of this practice in action. The state of Wisconsin provides funding and resources to support these programs. These groups then work together to support the adoption of innovative practices that improve water quality for the farmers and other community members within their watersheds. Wisconsin currently has 52 active producer-led watershed groups. If you're interested on additional information on UMRBA's multi-benefit conservation practice workshops, you can find that information at the QR code here. So, we talked a lot about the problems. What is UMRBA actually doing to address all of this? For the past year, UMRBA has been working on a collaborative project regarding state-level nutrient loss reduction strategies. Because water doesn't recognize political boundaries, it is UMRBA's goal to advance projects in the cross-border spaces and facilitate collaboration at the regional level to address nutrient loss. Nutrient loss refers to the transfer of nutrients, typically nitrogen and phosphorus, from the soil to water bodies. Nutrient loss can occur in a variety of ways, including urban stormwater runoff, stream bank erosion, and agricultural runoff. Nitrogen and phosphorus are key drivers of hypoxia in the Gulf and contribute to degraded water quality in the upper basin. To address the nutrient loss of nitrogen and phosphorus, and in accordance with the framework drawn out by the Hypoxia Task Force, states have worked to develop priority watersheds for nitrogen and phosphorus loss. These priority watersheds were developed through a combination of field and long-term monitoring station sampling and computer monitoring of nutrient loss. I like these maps because if you look at them, you can really kind of see how the water flows across the landscape down to the river. You can see this looking at it at the regional scale. By comparing the maps, we can also see that different nutrients can pose challenges in different areas. UMRBA is working hard to address nutrient loss in the basin. We're taking a three-pronged approach to the issue, focusing on nature-based solutions to this difficult and complicated problem. Alternative cropping systems, wetland restoration and conservation, and edge of field practices make up those three prongs. And we're going to look at each of those in detail on the next slides. First, alternative cropping systems. Alternative cropping systems refer to a variety of agricultural practices meant to leave cover on the land and prevent runoff and curb nutrient loss. Some examples of alternative cropping systems are cover crops, no-till, and continuous living cover. Cover crops are when farmers plant a crop in the fall that will remain in the ground over winter, keeping roots in the soil and vegetation covering the land. This crop is either then harvested in the spring for additional revenue or terminated prior to spring planting. The map on the right shows the percentage of cover crop usage in the upper basin. As you can see, the percentages are pretty low, and we still have a long way to go to increase the adoption of these practices. Conservation tillage practices keep post-harvest crop materials on the land, allowing for their biomass to break down into the soil and improve soil health. These practices are sometimes managed with a roller crimper, which is the implement you can see in the central photo. These implements work to terminate the cover crop by breaking up the plants without tilling the soil, leaving a dense weed-suppressing mat of cover crop biomass on the soil. Continuous living cover is the growing of crops that are perennial and can be harvested multiple years while leaving the plant in the ground. An example of this is a stillflower seen on the left, which can be harvested multiple years from one planting. Stillflower produces oils, which can be used in cooking or cosmetics. Our next practice is wetland restoration and conservation. Wetlands provide a multitude of conservation benefits. Acting as nature's sponge, they filter out pollutants and reduce flooding. Wetlands also act as nutrient sinks, holding nutrients like nitrogen and phosphorus in their soils and keeping them from traveling downstream. Examples of wetland restoration projects include stream rechannelization and floodplain connection projects. Of course, the best course of action is to preserve the small amount of undisturbed wetlands that still exist. Edge of field practices are designed to slow, filter, and process both surface and subsurface runoff from fields. These best management practices are placed on the edges of fields or water bodies, typically in areas where the farmland is less productive. Practices include bioreactors, which you see on the left and we'll talk about in a second, prairie strips on the right, and constructed wetlands. These practices trap nutrients as they leave the field before they can enter water bodies. Bioreactors use a filtering media, which is often wood chips, that's what's depicted in the yellow box, to intercept runoff as it leaves a field and filter out nutrients before discharging the runoff. Prairie strips utilize the deep root systems of native plants to slow runoff and trap nutrients, as seen on the right. So, now that we've talked about all the work that UMRBA is doing and all the problems that they're trying to address, how can you get involved? There's a lot of ways to get involved to help protect the water quality in the Mississippi River. You can get involved at the personal level by limiting the use of long chemicals, fertilizers, pesticides, weed killers on your property. Also, we didn't talk about it a lot today, but you can limit the use of salt that you use in your driveway or on the sidewalk in front of your house. Make sure to not sweep leaves or lawn debris into the curb and gutter system, which often drains to local water bodies. Like at my house, it drains to the Mississippi River, which is right there, 2 blocks that way. Or help by joining a community refuse cleanup near a local water body by you. At the government level, you can participate in the public comment period for water-based projects in your area. I know that for the Hispanic Access Foundation, ensuring that your voices are heard is an important tenet. This is a great way to share local and personal perspectives on projects that are being built now in real time. The public comment period ranges in scope from U.S. Army Corps island building projects in the Mississippi River to local watershed projects such as the construction of a stormwater retention pond or other water infrastructure projects. Look for notices posted in local news sources or sign up for notifications from your state management organization. I get my notices from the Minnesota Pollution Control Agency, which is our local water regulatory body. You can also join a network. One Mississippi has an amazing resource of water organizations all up and down the river, which you can see an example of in the map on the screen. The QR code in the top right corner links to the One Mississippi website, where you can explore groups and organizations that tailor to a variety of interests from hunting and fishing to ecological conservation. It all works together to make the river a healthier, happier, cleaner space for all of us. Thank you so much for listening to my presentation today. I hope that I've increased your knowledge of the state of the river and what we're doing to work on it and how you can help. Again, my name is Josh Wolf. I work for Upper Mississippi River Basin Association. I'm the Water Quality Program Lead, and I'd love to take questions from you. Thank you again. Thanks, Vanessa.
Thank you so much, Josh. We did have one question in the chat earlier. It was, can you remind me what HUC stands for?
Yes, it stands for Hydrological Unit Code. And that is just yeah, the USGS, the US Geological Survey, broke up the entirety of the continent into watersheds of 14 different sizes from Huck 1, or excuse me, 12 different sizes from Huck 1 all the way down to Huck 12. The Huck 1 is like the entire continent, and a Huck 12 is about 5 square miles.
Interesting. Thank you. And while we wait for more questions in the chat, oh, I have one here. What efforts for plants that absorb nitrogen have you considered?
What efforts for plants that absorb nitrogen have we considered? So,
Mhm.
cover cropping is one of the ways that we can absorb nitrogen out of the soil. Oftentimes, the cover crops that are planted will be nitrogen fixing plants, which then take up the excess nitrogen. So, um, there's a lot of different cover crops that are planted, like um, winter wheat is one that is very common. Cereal rye is another plant that is very common. Um, Oftentimes, it's blends of different plants. People use clover and radish as well. So that's there. Those are some examples of nitrogen fixing plants, but also farmers use crop rotation to plant nitrogen fixing plants as well in their regular cash crop sequence.
Thanks. Good question. I have another question in the chat. I wonder what specific personal actions can a Latino person living in an urban area can do to improve water quality?
That's a wonderful question. Um, Again, we have kind of there's kind of the three different ways in which you can get involved, right? One of those would be get involved with your local watershed district and see if they have any opportunities to volunteer. When I worked for the watershed district previously, one of the things that we would do occasionally would be community cleanups, where people would gather to go to the creek and just help clean up trash, particularly in the spring. If you're in an area that has winter, the trash accumulates over the winter, and you have the spring melt, and then you go, oh my goodness, where did all this trash come from that was under the snow? Um, Again, participating in the public comment um, process can be really important. It's not something that a lot of people take the time and opportunity to do, but bringing your personal perspective to a local infrastructure project, such as a stormwater pond that's being built in an area, maybe that's taking up land that was in a park, for example, and that's not going to work for you, right? Just making sure it's a great opportunity to let your voice be heard. And then I'll go back to this because it's just so great. You can see on the map here, if you live near the river, there's probably an organization that is close to you that you can join to get involved. Then the list that One Mississippi has there has a variety of different like interest type organizations. If you're interested in specifically water quality, or if you're interested in land conservation, right? If it's something you're interested, there's an organization out there for you to join. So there's a lot of different ways that you can get involved. That's a great question. Thank you for asking.
Thanks, Josh. And kind of touching base on that, I did hear, which I didn't know about salt being such a big pollutant. What would be an alternative to that?
Well, you can use sand is one
Mm,
alternative that you can use, but that also contributes to total suspended solids when it drains. But as we saw, those are decreasing, so it's a much better trend than it is for the chloride. The thing about chloride is that once it's in the river, it's pretty much in there. It's really not something we can take out. So when you are salting your sidewalk or you're salting your driveway, just be really mindful about how much you're putting down and how often. And, like read the bag. It's like it is a lot less than people think will melt a lot more than you think it can. And also, don't use it if it's too cold. There's a lower limit to what salt will work, and if you put it down and it's too cold, it's doing nothing. It's just gonna end up washing into the water body. We're actually through we work with a group that's called Winter Salt Awareness Week, and they work with one of the biggest issues that we have is like a big box stores, like a Target, your grocery store, for example, because they have these huge parking lots and they salt them all winter long. And so Winter Salt Winter Salt Awareness Week um, works with the applicators, and they work with the municipalities to help reduce the amount of salt that's being put down in those large parking lots and this at municipal owned properties and at corporate owned properties as well. And um, we're looking towards getting some legislation passed um, to advocate for some legislation to help reduce the amount of salt that's applied in the northern areas because we saw those trends. It is 35% increase is a massive increase, and it has the opportunity to have a really negative effect on the aquatic life living in the river. So thanks for asking us.
yeah, that's such an interesting topic. I have a couple more questions from
Of
the
course.
chat. If you can tackle only one problem of the ones you mentioned, what would it be?
Oh, okay. Um, so that's I think the easy one for me is cover crops because they really have an outsized effect on how they're able to keep um, the nutrients on the ground over the winter time and avoid them running off in the spring. I just, I grew up, my dad grew up on a farm, on a dairy farm, and my uncles were farmers. My wife grew up on a dairy farm, and her dad still plants crops. And so I just grew up around that. The innovative nature of that aspect of farming is really interesting to me because when you asked about the nitrogen fixing crops, just the different variety of crops that can be planted based on the different areas of the country in which we can plant these is just it's so interesting. It's really, people have been planting cover crops for a really long time. Some farmers have been doing this for 30 plus years, but there really is a big push currently to get more of this happening. And so seeing the emerging markets that are coming along um, for these cover crops and how that might be able to drive additional income for farmers is just to me it's fascinating stuff and it's really cool and can have a really big effect on the nitrogen and phosphorus coming off the field. So that's the one that if I could had to pick one to work on,
That
I'd
one
just work
hits,
on cover crops the whole time.
it hits close to home. I have another question.
Mhm.
Um, Thanks for the one Mississippi shout out. Love to hear more about um, UMBRAs and your work. And I'm curious that pollution trends that spanned from 1989 to 2018. Did you mention if there is an updated plan?
So we are we're that's why we're doing the fixed site monitoring right here. I'll just go back so I can talk about that. So that's where the fixed site monitoring comes in. We're looking to have an updated body of data to base a new. We'll end up writing a report, an updated report on all of the sampling that we've done from the river for this year, and this will be, one of the largest, most comprehensive sampling projects on the upper river that's ever been done. So it's going to bring us a new body of data, particularly with those emerging contaminants, a lot of which have been sampled, but none of which have been sampled at this scale, and that number of species of pesticide and PFAS, if you will. So yeah, we're looking to update that information, and yeah, we'll hopefully have the report out in early winter 2027.
Perfect. And then I think in addition to that, what about industrial development in and on the river? How does this affect the pollution numbers? Example, we are trying to stop a barge terminal from being built.
So so the barge terminal is a little different than in industrial sources, and I didn't really talk too much about that today. But industrial discharges are what are called point source polluters, and those are managed through what we call a NIPDES permit, a National Pollution Discharge Elimination System permit. And so there are strict limits on what they can discharge. And um, basically, a lot of the progress that's been made on the the phosphorus discharge has been because of increase like strictness in these permits and increased monitoring and compliance with the permits. As far as industrial pollutants, those are also monitored under these discharge permits. Um, but yeah, as you saw, like there are metals in the river, right? We have lead, arsenic, zinc, aluminum. If you look at the How Clean is a River report, there's a few more that we um, that we did analysis on when we wrote the report that I didn't have time to talk about today. The good thing is, excuse me, as I said in the presentation, all of these are far below the chronic health limits for these chemicals, and so they're not particularly damaging to us at the concentrations they stand in the big river. That's not true for every water body, but in the big river, that's what we're seeing. And also, they are so far away from uh, chronic aquatic life health risk. Again, that's in the big river, not everywhere, but in the big river. So right now, we're not saying that these chemicals aren't there and it's not important, but right now they're at a place where they're okay. That being said, every additional factory that's built on the river is additional discharge that's going into it. So it's always important to be looking at these projects and monitoring that discharge. And so a lot of that comes down to permitting.
Perfect. Yeah, and I saw that they meant the effects from loss of habitat from development. So yeah, perfect. And I guess one last question.
Of course,
For those of us listening today, what gives you hope when it comes to the future of the Mississippi River Basin?
thank you. This is a great question. I work with a lot of really impassioned people every day. Um, a lot of people who've dedicated their entire career to this, 30 plus years. And like to a letter, the people that I work with closely just like live and breathe this work and are so dedicated. And that's what keeps me going. Also, I do think that, um, you know, since I was, I guess, in high school, right? I think we have really seen an uptick in the way that people think about conservation in their personal lives, right? More people are thinking about conservation more often than ever before. And I think that that is going to help drive the future of this, right? The more that we're talking about it, the more that people are actively engaged, right? Just all makes it better. Even if the only thing that you got out of this presentation today is I should put less salt on my driveway, that's still great, right? Like every little piece makes the puzzle just that much better. Sometimes it's hard, when I'm looking at this big nutrient work, the trends is, from goes to 2035, right? It's such a big problem. The scale is so big, but I have to remind myself that like the little things all still matter. And even if we only each do a little bit at a time, it really does add up to make a difference. So that's what keeps me in it.
It's those small changes, right, that can have a big impact at the end of the
That's right.
day.
Yep.
Well, thank you so much, Josh, for sharing all your expertise, your knowledge, and insights with us today. And thank you all for joining and taking the time out of your day to be here with us. And thank you to Natalia, our wonderful interpreter, for being here today. And as we head into Earth Day tomorrow, today's conversation is a powerful reminder of how vital it is to protect our water sources and the role that we all play in safeguarding them for our future generations. And I'll share all these resources and the recording later this week. And we appreciate your time and engagement. And we hope that today's discussion leaves you informed and inspired to take action, even if it's a small one. Thank you so much, everyone. Have a great day. And we'll see you again. Thank you, Josh. Thank you, Natalia. Bye, everyone.